For these problems, it's really important. What I'm trying to get into your heads is the importance of what you show. And I've been looking closer and closer at the released free response questions. And as the years go on, they actually have been doing a lot less pure computation and more interpretation and focusing more and more and more on, do you understand why you're doing what you're doing and how they all fit together. So when we're looking at this, for that first part here, and again, this is very common approach to it. Usually you'll have at least one question like this straightforward on your AP exam. Now, it might be one proportion, it might be two proportion, it might be counts. There's all these different types of tests, but one general setup where it says, do it. And the work that you need to show in here, I'm actually missing one little thing from this, so I'll talk about when we get to it. You need to make sure you identify what your parameter is. In this case, P is the proportion of subjects who reported drowsiness. We okay with that? Nope. And the reason why I'm saying no is there are a ton of side effects beyond drowsiness. We are just specifically looking at this one thing. Okay. Also with this, I labeled mine as P hat I and P hat C. If you wanted to talk about them as group 1 and group 2, you would just need to write down brand I equals 1, brand C equals 2, however you'd want to do that. And I'll get to the order of things in a little bit. Yeah. Perfectly fine. All I'm trying to point out is if you're kind of trying to cut out that step and you're using a notation that clearly identifies what your groups are, you don't need to sit out and identify it separately. Okay? But I totally recognize doing group 1 and group 2 because in your calculator, it's X1, N1, X2, N2. So if you want to stick with that, no problem, go for it. And what I have here is I have listed out my P's and my sample size. I put the decimal simply because when I'm going to do my formula, it's a little bit easier in this case to do the decimal. It's just slightly less writing than the fraction is, but that's up to you. Now, please check your work. Did you state someplace in your conditions random? If you did not write the word or the words randomly assigned, please do that. Underline it, highlight it. That is huge. Because when we're talking about experiments, not only does those folks in group I can't affect the folks in group C, but how they got into those groups. The random assignment is huge. Okay, when we're talking about experiments, things get a little bit kind of grayer sometimes when it comes about your assumptions and conditions, because usually you're dealing with volunteers, which we've talked about, like that whole voluntary response bias type thing. Might not be 100% representative, so we have to kind of get what we can. So the treatments were randomly assigned, and in stating that, I'm actually talking about both random in the groups and random between the groups. Because when we're talking about two groups, you have to have that. Remember, you have to have independence within the group, and then that additional assumption of independent groups. So kind of specifically listing out here independent groups is what I'm missing here. Now, for experiments, sometimes if you look at the textbooks or the free response questions, they'll say you don't need to check the 10% condition for experiments because odds are you're not going to get more than 10% of a population to do an experiment on. I mean, like if we have only 80, silverbacked rhinos. I think I saw on the news that there's like a very, very silverback African rhinos is I think what they were. There's like less than 80 of them left in the world. We are probably not going to do an experiment on 10 of them. And even with that, we're not going to have like the success failure that we would need. So when we're talking about experiments, it's not like a deal-breaking condition. The large enough condition can be a deal breaker though. So I don't care if you tell me which number is which. Just make sure that you list out each of your numbers. So 14, 66, 22, 58 are all of my success failures. They're all bigger than 10, so they're large enough. Now, I don't know why I did C minus I. I'm special. I want to be different. I noted that here. Did you write someplace in your work what order you did your difference in? If you didn't, write that down. It can be as simple as C minus I or I minus C, but you need to put that clearly defined someplace. And just putting the numbers in this order, that's not going to be enough. Because people write them down in the wrong order sometimes. You can't get penalized for that. Yes? When you're talking about a confidence intervals don't have hypotheses. Okay? And we are going to be doing hypothesis tests today. All right? If you had done I minus C, these two numbers would have been flipped. This is basically the same thing. Your first number here would have been negative, and then these two numbers would have just been flipped. So you would have had negative 0.228 to positive 0.028. And I don't care which way you give it to me, as long as you're clearly defining what your order was. Yes? I'll tell you why I did it here. Because literally writing p hat 1 minus p hat c, or p hat I minus p hat c, took up more time than just writing 0.1. And that's really what I default to. I go, how can I get away with writing the absolute least amount? But I'm perfectly fine with you doing p hat I minus p hat c, or 1 minus 2, or however you want to do that. It's fine. Okay, just again, you got to make sure you're clear on the order. And rather than saying z star equals, again, I'm like, hey, look, shorter step, just put the z star in there as 1.96. Do you have 1.96 identified someplace, either in the formula or off to the side? Because remember, that's not something your calculator is going to spit out with the interval. You have to find that yourself. And then we have the conclusion. We say, based on our sample. Now, I wrote in what my samples were. That's not really a deal breaker there. We are 95% confident that my population parameter that I'm interested in here is not just the proportion, but the difference in proportion. So check your answers. Did you put difference in proportion down in your sentence? Good. I'm seeing a lot of people nodding. I see a couple people writing it in. Make sure you do that, because it's not just the proportion. If the proportion is between these two things, I got a big mistake because I got a proportion that's negative. Differences can be negative. So the difference in proportion of patients who reported drowsiness or who would experience drowsiness is between, and again, in your conclusion, make sure you're identifying which direction you're subtracting in. Yes, ma'am. No. The 17.5 and the 20, whatever that is? No. I did that simply because I did that. You're welcome to put extra info in. You just can't leave necessary stuff out. So what did we think about this? What did you leave out? What did we miss on this? I'm not expecting perfection here. Okay. Yes. It's similar to saying assume samples are representative, but in this case, they actually state random assignment. Only really go with the representative samples and say assume a representative if they don't specify that word random in there. Okay? Because a random is, we do that to try to get a representative sample. Does that make sense? So you can use that assume representative if they don't say the word random. Good questions. Yeah. The 0.1 came from the 27.5 minus the 17 point, the difference in the proportions. Again, lazy me looks to find the least amount of stuff to write down. I'm good with y'all doing that too. As long as you show what you need to show. Always, when we go through these stuff, guys, don't sit there and say, oh, okay, I missed this. I'll get it right the next time. you have to kind of acknowledge your mistakes, point them out. Otherwise, your brain's just going to do the last thing it did. It's not going to make that change. You do. When it is, well, obviously when it's a 2-portion Z interval, but you will always have some sort of a statement as to what kind of a test or procedure you're running. But it's 1 prop Z test, 1 prop Z int, 2 prop Z test, 2 prop Z int, and when we get into the next section, it'll be means, and then we'll do counts, and then we'll do regression. So depending upon what it is. Yep. I'm sorry? You can do 2 prop, not in this class. There are multiple comparison tests. One of my favorite names, Tukey. A Tukey test does a multiple comparison. I just think it's fun because it sounds like turkey. The Tukey test. Okay. And then the conclusion, the last little piece of this, because the interval contains 0, we do not have enough evidence to claim there is a difference between, right back to the beginning, the proportion or the rate of drowsiness for the 2 treatments. Yes? That's perfectly fine. Yeah, it's just taking the opposite direction for that. They're saying that there is no difference is the same thing as saying we have evidence that they're equally effective. Okay. And today we're going to be tacking on a little bit with this because usually you'll have a straightforward hypothesis test or confidence interval question like this. And then typically as you go through, there'll be another one that usually tacks on additional questions, whether they're saying interpret errors, interpret power, or they say what's the corresponding test or confidence interval, whichever opposite one. All right. And speaking of that, just a reminder, your quiz is going to be when? Flex Wednesday, because I will not see you on Monday. Tuesday, yes, thank you. I will not see you on Monday. Monday you only have 5th and 7th block. And therefore we will be doing the quiz on Tuesday of next week, but when is your homework due? Tonight. Okay? All right. And on your quiz is 20 and 21. So that means alpha, understanding alpha, errors, type 1 and type 2, power, and then the 2 proportions. And I'm telling you right now, it is not going to be a multiple choice quiz. It's going to be more short answer pieces. Trust me with this. You guys tend to do much better on the free response than you do on the multiple choice. Okay, so this gives you that opportunity. Plus, it's basically, I'm trying to get you to write these sentences that I've asked you to remember. Okay, that's the majority of the first page is, do you remember your sentences? Can you apply them in context? And then the back page is, hey, here's a 2 proportion something. Okay? Wow. Do you ever feel like that? That's Adam Sandler. Billy Madison. Oh my God, I'm so old. But in Billy Madison, he has to go back to kindergarten and pass every single grade up through high school or else he doesn't get his inheritance. And he's like in, I don't know, like the 3rd grade or something, and he finally got questions right. He went, I am the smartest man alive! Yes. Yeah, like the 3rd grade teacher or something. It's not him, it's Hollywood, so, you know. All right. Now, I want you to read through these instructions, guys, please. I want you to read through these very carefully. I will tell you right up front, don't worry about writing down your assumptions and conditions. We'll go through that together. I want you to do the intervals they're requesting. So that means that you can skip the assumptions and conditions. But please write down everything else. Okay, so it should cut out a lot of the writing for you. So even though I didn't ask you in this problem to write down your assumptions and conditions, I told you we go through them together. Just figured to save you guys a little bit of time. What are the assumptions and conditions I would need for these problems? Random. Do we have random? Yeah, because even though they're talking about a randomly selected group of patients, they were then randomly divided into the two treatments. So we have randomization. What else do I need? 10%. And 112, 108, those are definitely going to be less than 10% of people who suffer from this kind of joint pain. Right? This is a relatively small group. What else do I need? Success failure. So I've got 84, 66, and the flip side of that would be 28 and 20, 40, 42. So all those numbers are bigger than 10. We're good enough. Now, for each of these, we're doing sampling distributions that are based off of each individual sample. So for this guy, where would this sample for A be centered at? 0.75, I assume that's 84 over 112. And then the standard deviation, that's the root PQ over N. Okay. So when we look at the actual work for this one, it would be centered at that 0.75 or whatever 84 over 112 is. This here would be the standard deviation. It's just in a non-AP class, they don't make you always write that, but in AP they do. And you can see here, I am fine if you've listed out your bits and pieces. I'm perfectly fine with you writing just this guy out. Just the formula, that's okay. You do need to make sure that you identified that Z star was 1.96. Do you guys have that on yours? And what's really nice is because the second problem is still dealing with the same thing, it's the same Z star, you don't need to write it again. When you're doing one problem that keeps filtering through, once you've checked something once or stated it once, you don't need to repeat yourself, which is really, really nice. So I have my intervals. The first one should go from 87 to 83%. The second interval goes from 51.9 to 70.3. You guys get those two answers? And we have our interpretations. We're 95% confident that between that stuff up there and this stuff down here, of patients with joint pain, we'll find the medication A to be effective. Actually, if we're looking at this, yeah, this one wasn't the drowsy. I get this mixed up with the drowsiness problem. So we're okay. So does everybody have those for their answers? Any questions on this? Now, if I wanted to compare medication A to medication B, would you say that there is a difference between the medications? There's not enough evidence? Why? 100%. There's not enough evidence to say if we look at these two separate intervals. Because if we look here, from 67 to 70.3, those intervals overlap. Right? And so if I look at these two samples separately, this kind of goes to the next question. Do the intervals overlap? They do. This would mean if I look at it this way, there isn't a significant difference between the two. I wouldn't have enough evidence to claim that. What I want you guys to do is I want you to now go back. Just do the 95% confidence interval for a difference in proportions. Do you understand what I'm saying here? So you're going to do your confidence interval, not a 1-prop, but the 2-prop confidence interval that goes with these guys. And we're going to see what we get. Okay? All right, so do you guys get your 95% confidence interval calculated? When we're doing a difference in proportions, there is that one more condition that we need. What is that? Independent groups, right? The groups need to be independent from each other. And the way that we reach that with this is the fact that the patients were randomly assigned to the two groups. So that random assignment is a really important tool for us. Now, what did your 95% confidence interval for the difference end up showing? What did it say? 0.0169 to 0.2609. Okay. Now, does that interval contain 0? So looking at it from this perspective, do we have enough evidence to claim that there's a difference among the medications? We do, because the entire difference is above 0. I can actually claim that which one is better. No, of the A and B. A, because if you're doing A minus B and your answer is positive, that means the first one was larger. So looking at this answer tells me that A is the better choice. But now we have conflicting evidence, right? We look at the single sample confidence intervals, but they overlapped. We do the difference in the portions. They don't. They tell me there is a difference. Do you see how those two are slightly different? Anybody understand why that happens? Any idea? Think about it this way. When we are talking about comparing the two single intervals, we have the standard deviation from A, and it's like, let's say it's that wide. I have the standard deviation from B, and we're looking at them flat like this. So it looks like if we were to compare them, we have a much greater standard deviation. But we talked before that when we're combining random variables, do standard deviations add? No. One more time. Variances do. And variances make more of a right triangle. And that's your Pythagorean identity. So it actually has a smaller variance than what you would expect. Okay, and I know sometimes you're kind of looking at me going, I'm crazy. That's okay. Just understand that it's very important when you have two groups, because of what we did with our random variables and how we compared our means and our standard deviations with that. It's not a straight up linear combination. We don't just say standard deviation of one plus the standard deviation of the other. The formula for this, when we're doing this guy, is we take the variance of the first group plus the variance of the second group, and then we take the square root. Okay, so it actually has a smaller standard deviation, which gives us a little bit more accuracy, which gave us an interval that did not contain 0. So whenever you see two different populations, two different groups, even if you started with one group and you separated them, as long as your groups did not get the same thing, because that would invalidate your independence, as long as group A and group B were completely different groups, do a 2 proportion test. Don't just do multiple 1 proportion tests. And kind of going back to what you were saying before about can we compare more than 2, the problem with when we compare more than 2 is that standard deviation relationship gets weirder and weirder and weirder. And so we have modifications in like the Tukey test that helps us kind of deal with that. It's a really cool thing that happens. And it's because when you're looking at, even in education, they're always looking at what they call subpopulations. They break down groups. They break them down by gender. They break them down by ethnicity, religion, income, and they look to try to see if there's difference within these groups. And so these types of tests are very important because they allow us to examine that. Okay? So today we're taking just one last little thing with this. We've done the confidence intervals, so today we're doing hypothesis tests. Okay? Now, the nice thing about the hypothesis tests is that they're very similar in structure to what we've done. Now, this is just a reminder. None of this that's up here is new. You shouldn't have to write down any of this. This is straight from the Z interval stuff. We know that all of our intervals are done, and they're centered around what we observe. So in this case, that's p hat 1 minus p hat 2. They're always plus or minus our test statistic. And when we talk about proportion, that's Z. And our standard error. And this was just the formula that we used for combining two standard errors. Okay? So none of that's new, right? And when we did this, we said we could only do it after we've checked our assumptions and conditions. Again, all of this is still the same. So we have to have random. So each group needs to be randomly selected. And if you're looking at comparing between two groups, we want random assignment to the groups as well. And that kind of gets to your independent groups assumption as well. The 10% condition is kind of like, if you know that you have a limited population, you want to make sure that you check that. But it's not going to be like a deal breaker, typically for us. Sample size, Each group must be big enough, so that's your success failure. These things are not changing. Do you understand what I'm talking about here? Hypothesis test, confidence interval, exact same. What changes for a hypothesis test is the fact that our null hypothesis, when we talk about hypothesis tests, they're all based on what? The population parameter, the hypothesis. Whereas a confidence interval is based off of the sample, the statistic. So in my hypothesis test, for all of our hypotheses, we generally start with the idea that the null is that there is no change, right? So the null between two proportions, if there is no change, what are we expecting that difference to be? 0. So the null hypothesis is going to be that that difference, again, not using p-hats, just the p's, is 0. And the reason why that gets a little weird is because we've been saying for hypothesis test, you always center it at that number, and then we use that number to find the standard deviation. If I use root PQ over n and I'm using this number, that's going to say I have 0 standard deviation, so I can't do that. So we have to think about how this relates to the whole context. Think about it this way. If I want to compare the proportion of female students who get accepted to Virginia Tech versus the proportion of male applicants that get accepted to Virginia Tech, okay? I'm initially going to say I don't believe there is a difference in those groups. So if I don't believe there's a difference in groups, why group them together at all? Does that make sense? If I don't think there's a difference between males and females, then don't even break them in. Just say total accepted out of total applied. And that is very important. That is called pooling. Y'all ever heard that term before? To pool? You pool your money to buy a pizza. Or you pool your resources to get something done. Or you're playing poker, and all your money goes in the pool. Well, what a pool is basically saying there are no groups. It's just one group. And it's very important when we're talking about a hypothesis test that you always pool in a hypothesis test. You only pool in a hypothesis test. Because again, hypothesis test is based on that null, that belief that there is no difference. So if there is no difference, then we're just going to put all of my successes out of all of my trials together. And that's the idea of pooling. It's important that you know this because even if you forget that you're pooling and you're doing it in your calculator is going to remember. But you will lose points in your formulas if you don't indicate it. Okay, and that's where we kind of got to be a little bit careful. So this is really the big thing here. You're going to pool in a hypothesis test. Now, what does that look like? Okay? How you pool. This, for some reason that looks a lot harder than it actually is. You just take all of the successes plus all of the successes divided by all of the people. For example, if I'm pooling the proportion of female applicants that were accepted and the proportion of male applicants that were accepted, I would just say all people who were accepted divided by all people who applied. That's what this is saying. And you always want to identify this, and you actually, I know it's annoying, you have to identify it as p-hat pooled. Pooled. P-pooled. Important that you show that. So basically what I do is when I go through this, I've got my parameter defined. I have my bits and pieces written down. I check my assumptions and conditions, and I write my hypothesis. And then I immediately come around and I state what p-pooled is. Because p-pooled is going to actually kind of affect, and this is just a reminder if you can't see your successes, that's how you calculate them. P-pooled is going to affect how you calculate your standard deviation. And remember, when we're talking about successes and failures in your calculator, I mean, this was on Facebook yesterday, teachers taking a picture of their calculator. Why isn't this working? Your calculator will not work if you put decimals for x1, x2, n1, n2. Okay, so just remember that. Yes. Yes. Okay? And that is the only time we ever round. It's putting that in the calculation. So we get a standard error formula that looks like this. It's a little weird. Basically what this is saying is that they're saying like a standard deviation, we do root PQ over N. Well, PQ, P pooled and Q pooled. But we don't have just one N, we have two of them. And so what this does is it allows us to talk about the proportionality of those two groups together. Sometimes you'll see that as P pooled, Q pooled over N1 plus P pooled, Q pooled over N2. But that's just a heck of a lot more writing than I'm ever willing to do. So I like to do it this way. And this is actually the way that they have it represented on the AP formula sheet as well. And we're still calling this the standard error, but we're specifying down here that it's pooled because it's still, I can't base it off of my null. My null was 0. So it's always a standard error when it's based somehow off of our observations. But again, they're typically not going to mark you off if you say standard deviation. I just want to make sure that you always identify for a hypothesis test that it is pooled. That's important. Okay? All right so far? Now, really nice. The rest of the proportion, the rest of a 2-prop Z test is very, very similar. When we do a 2-prop Z, when we do any type of a Z test, we do identify your proportion, your parameter, bits and pieces, assumptions and conditions, hypotheses, describe your distribution, name your test, and what are the calculations I need to show? Test. I need to write down, would need to write 2-prop Z test, but what are the actual numbers that I have to show? My actual calculations. Like I have to show a formula of some kind. The what? The normal model will be in there, and it's part of the calculation, which is in there. I'm trying to get to the Z. You need to figure out your test statistic. Do you remember what I'm talking about now? So I know, sometimes I expect you to read my mind, and my mind is slightly strange. Okay? So we need to show our Z calculation. How does my Z calculation differ? Well, first off, we know that my null hypothesis, you can write it one of two different ways. I don't care. I typically write it this way, P1 minus P2 equals 0, because I like to see the 0. That's my justification. But you see here, if I added the P to the other side, we're basically just saying they're equal. You pick which one of those you want to do. I'm not going to get picky on that. And to find your test statistic, if you remember, all of our test statistics are done by taking observed minus expected over standard deviation, right? Okay, so applying that in this case, the observed is what you saw your difference in proportions to be. This is Z. Z star is always the inverse norm. It doesn't change problem to problem. Your test statistic Z does. That's why Z star is a critical value. This guy is the test statistic. They're all Z's, whatever. So what I've got here is, again, my Z score is always calculated by saying observed, so that's my difference, minus expected. This 0, and that's why I like to write that this way, so I can see what my number is for the expected. But really, guys, do I need to write down minus 0? You really don't. I like to do it because it keeps me always doing the same steps the same way every single time. But if you don't want to write minus 0, you don't have to. And then here, make sure you're indicating that it's the pooled standard error. Yes. Sometimes we're not really going to, I've seen them try to do this to you once or twice, where they'll say, for example, we believe there is a 2% difference between males and females. And so then you would put 0.02 for that. Okay? All right. And then you get to use your normal model. Your normal model would be centered at the 0. It would have the standard deviation for SE pooled. And then you would just work it out. Okay? So we're going to work a problem start to finish all the way through. So look back at your notes because this isn't notes. Yeah, go ahead. Yep, Britlet. And today I'm going to try so hard not to say Candians or write down Candians because last class I kept writing Candians instead of Canadians. Whatever. And actually England is different than Britain because Great Britain contains all of those little groups that break off of it. Nope. Like Great Britain will include Scotland.
So it's not a country?
Right. The United Kingdom picks up all of those separate little groups. But technically, like when someone says England, they're not talking about Wales. They're not talking about Scotland. It's okay. Not a big deal. But, all right. So we have this problem. And this is a really good problem number 3, or possibly a problem number 4. The reason why I say that is because not only do we have a hypothesis test, but then they turn around and ask you to do a confidence interval also. And that sounds like it's going to be horrible, like a ridiculous amount of work. But the great thing about this is once you've stated certain things, you don't need to go back and state them again. Okay? So that second step is actually very little work. All right, so let's start working through this problem. What should you start doing for hypothesis test? One more time. State P. So if I look at this, guys, please focus. What is P gonna be? Cut out, because Britain and Canada, those are my groups. So cut that out. There you go. It's the proportion of people who read at least one book. Take out your groups when you're identifying P. That's a little bit of a separate piece there. And you want to be specific because it's not read at least one book in their lifetimes. That would be a very sad life. Dude, I think reading one book in the past year is just abysmal. I think I've read 2 books in the past week, so I don't remember. I read them on my Kindle so you don't see the title all the time. You read what? Okay, good for you. Good for you. All right, so this is what I've started with. Ladies and gentlemen, let's focus here. Shh. So we're starting with identifying our proportion, which is the proportion who read at least one book in the past year. Now, be careful when you're doing things like this. Don't use qualifiers. Don't use like better or worse or smarter or dumber. Who knows? Maybe the group that read more because they were reading books like See Spot Run. And the group that read less read War and Peace or Dostoevsky or Shakespeare, some book that's like heavy. Okay, so don't make those qualifying judgments. Just be careful with that. So once I've listed P, what should I do next? Before I do that, I go with my groups and I state what I have. Okay? And for this guy, what I would do, my groups are the Canadians and the Britons. And I go a little bit further when I'm talking about 2 groups because I know that I want to look at the success failures. So you'll see here, they gave me in the problem that P hat for Canadians was 0.86. Yes, sir? Yes. Britain is the landmass type thing. Someone from Great Britain is a Briton. Just like someone from Canada is Canadian. Okay, so what I have here, she just asked a really good question. She said, what was S and F? I knew I was going to need to use this later on So I went ahead and I wrote down my successes and failures. So that means, how did I find my successes? I multiplied my n times my p, but what did I need to do?
Round up.
And it's not necessarily round up. It's just round, period. Round to the closest integer. Okay, so, I mean, I could. The reason why I didn't is I know that when I'm talking about a hypothesis test, it deals with pooled. So I'm not really interested in that quite yet, so I didn't bother here. It's also going to be really important because we're looking at a difference that we do what? Right, specify what direction. You are really able to use whatever direction you want, but I would decide before you go much further, you want to do C minus B. So if you do C minus B, simpatico. If you do C minus B, it just makes sense to me to go from here straight into the null and alternative hypothesis. What would my null hypothesis be? P, there you go. PC minus PB equals 0. You're also welcome to write that PC equals PB. It's whatever you prefer. I just like this one because I like to see the number. That's my thing. Because a hypothesis test is always about what's true for the whole population. So every single hypothesis test will always be just P. It is a parameter. Guys, you are doing phenomenal today. Seriously. You are on point. I appreciate that. Now, let's go back and look at the question again. Because in order to determine my alternative hypothesis, we got to look to see what the question was asking. So if I'm doing Canadians minus Britons, what is my alternative hypothesis going to be? Greater than 0. Does everybody understand why my alternative is greater than 0? The question here says, do these results confirm a higher reading rate in Canada? So if I'm looking at a higher reading rate in Canada, if this is the bigger number, then C minus B would be positive. So that's why I have that. And you can think about it in this way as well, where we have PC is greater than PB. Again, I just like to see my numbers. I know. Ink keeps dying on that. Stupid pen. Are we doing okay? What would come next? Assumptions. So let's just kind of talk about our assumptions, and we'll flip back and forth to the question itself. What is one of my first assumptions? Random. Do you see the word random in there? Okay, so we have randomly sampled Canadians and Britons. So both groups were randomly sampled. Okay, so I'm going to put that down. We were told that they were randomly sampled. And you know what? Under randomization, what do we have next? Well, we did like the 10%. I've just got it pre-written, so I'm doing it in this order. So we have it. Really, my logic here. 10%. So I need to say what for my 10% condition? What is less than what? No. The 1004 has to be less than 10% of Canadians, and good job. Now, along with this independence idea, we talk about independence within my groups, but what haven't I done? between the groups. Now, with this one, we didn't randomly assign people to the Britain or Canadian group. You can't. So because I can't randomly assign somebody to be British or to be Canadian, we have to say that the reading habits are independent. So if we can't say that we randomly assigned to the groups, we have to say why the groups should be independent. How much the folks in Britain read should not affect how much the folks in Canada read. And feel free to abbreviate, for crying out loud. Canadian is a big word. No? It's too many ways to spell. Yes, and if you leave one A off, it's Candians. So should be. Because it's one of those things that we're like, yes, I can find a way that they wouldn't be. You can usually argue. But for this, we're going to assume. You can either say should or we're going to assume. And then I need one more condition. Success, failure. And really, all I need to do here is list them out. And that's why I had it calculated up here. I knew I was going to have to do it anyway. So 863, 141, 817, 192, all of those are bigger than 0, so all of them are large enough. Did I say 0? I'm sorry, 10, yes. So then what I want you guys to do, what would be next? The normal model. I want you to write down what you think that normal model would be. Describe that normal model. Describe your normal model. Now, this is what kind of a thing am I doing here? Math, statistics. If I were to look at my calculator, what would I be looking for? A 2-prop z int. For a 2-prop z int like this, where would my normal model be centered? Hypothesis test is always based. Yeah. The hypothesis test is going to be centered at that 0. No, we can't do that when we're calculating the standard error. Because if I'm using that as my standard error, it gets a little funky. Okay, so just like, and if you want to think about it this way, I am not changing the fact that in a hypothesis test, it is always centered at what the null hypothesis was, what that value is. That is every single time going to be the case. It's going to be centered at that null. The problem is I can't use a 0 to calculate a standard deviation. You're going to have a standard deviation. And that's going to be the formula I use for my standard error or standard deviation. And notice I actually wrote out pooled. Please do that. Don't write p hat, q hat. If you wanted to, how would we find p pooled?
It is essentially what we do is it'll be 1680.
We're going to be adding what? 863 and 817. And then you're going to divide that by? Yep, these two. Yep. Okay. So remember, we always pool in a 2-prop z test. The mean, I want to be careful with saying usually for a 2-prop we're going to be doing 0. But the thing that will always be true is whatever number is here is always going to be where your mean is. Okay? Because I might say, for example, that I think the difference between men and women in the past has been 2%. So then I would have centered this at 0.02. Okay? All right, guys? All right, so we're running out of time, so I'm just going to finish this out. We would have a 2-prop z-test. Since I've written all of this junk out, I'm not going to bother typing it in or writing it out here. I just write my formula. I'm sorry? The first one was a z-test. So if we go back to the first thing that we were asked to do is to test a hypothesis. So whenever they talk about testing a hypothesis, that is the test. It's okay. And I know I'm going to lose you in a second, so I want to talk about something real quickly. Do I have your attention? Before you guys go, please listen. The next thing said to do the confidence interval. Note that for the confidence interval, I've already checked assumptions and conditions. Don't do it again. Just say they were met. Change your mean to the observed, change your standard error, find the confidence interval, and then interpret. But all of that stuff that you did before, you do not need to do again. That's the big thing that I'm trying to point out here. This stuff will be on the quiz. We're going to have time before the quiz to answer more questions. We'll try to do one more full problem. Okay? And just so you guys know, your homework is due when? Tonight. Your quiz is going to be when? Tuesday. Thank you, ladies and gentlemen. Seriously, you were amazing today.